Okay, that was actually a great setup for what I'm going to talk about. So today I'm going to talk about writing your own code coverage tools in Python and some interesting bugs that you run across when you do that. So we're also going to look at my favorite thing, bytecode in Python. This is two simple functions. One, these are basically defined as functions so that we can pass them to the disassembler and get a feel for what the bytecode looks like. So here we have an if statement and a loop. And the thing that's interesting about this, we'll take a look at the disassembly of the if statement, is that internally, Python is basically using gotos to do control flow. Like so we'll say, pop jump if false says, if this thing is false, jump to, in this case, position 10. Otherwise, continue executing. You can see that this is the line numbers on the left, and it maps to line 3, which is the body of the if, and otherwise we're going to jump to line 5. Another thing to notice is that the else does not appear anywhere in the disassembly. There is no line 4, because else is a no-op, right? But by the time we finish an if, we know which branch we're going to, the first one and the second one, so there's no further work to do. You can also take a look at the loop, and it operates on the same principle. In this case, the iterator is either going to continue executing or is going to jump to the end of the loop. So here we're going to land on 38, which is when we're basically done, and they're just going to return the value from this function. So here we've got this great example. So we are thorough programmers. So of course we're going to write some tests for them. We're going to make sure that they work the way we think that they do. So here's the world's simplest test runner where we're actually just writing assertions and then running the tests by calling functions. And we also want to know how we're doing on code coverage. Do the tests that we've written cover all the lines of code that we wrote? So using sys.setTrace in Python, this sets a trace function on the execution, and we've defined a custom function, this trace here. It has to take these three arguments, frame, event, and arg. And this means that every time there's an event in Python, we'll get a handle on these variables. Events are things like lines of code being executed, or function calls, or function returns. This is really powerful, and you can do a lot with it. So in our case, we're going to use this to build up a list of the line numbers of the code that actually executed. And then when we're done, we'll take a look and see what code did not execute, and that will be informative for us. And we're also going to drop out empty lines, because empty lines we don't care about. OK, so let's go ahead and run this. OK, so right off the bat, we see the problem that we expected to have, which is the else shows up as missing. So we can think about this in Python syntax being what it is. Most of the time, you probably won't have an else on a line with other code. Like you could, but maybe you just shouldn't. So we'll just say, OK, just drop out the else's. So we'll just modify our filtering to exclude else and empty lines. So let's run this second version with only that change and see how we do. Great, 100% coverage, awesome. But we're not off the hook yet, unfortunately. There's another case where jumping will make it look like code that has in fact executed has not executed. And that example is with continue. So this is a slightly more complex example that all three of these values should be 50 at the end of this sample. Can you see this OK? So basically, we're counting every time we get an even number or an odd number, and then continuing on the odds, so we should come out to half. So being thorough developers, we will write a test for this, because we expect to get 50, and we'll add it to our little test runner here. Let's go ahead and run this. So we got this continue, but we know what to expect here, right? So we said, OK, when we looked at the disassembled bytecode previously, we saw that else didn't appear. So if continue also doesn't appear, then probably the same thing's going on. And we can just sort of wave our hands about that one, too. So here's the disassembly of the continue function. And you'll see that there are, in fact, things that are happening on line 19, which is the one that has the continue line on it. So what's going on here? The bytecode is telling us one thing is happening. Our code coverage tool is telling us a different thing is happening. Unclear who to believe. And it turns out what's going on is that the only thing that happens on line 19 is a jump. And so the compiler sees that you jump to that line off of an if statement, and then you jump away from it. And it's smart enough to say, well, if you jump and then you jump, you should just do one jump that covers both of those instead of two jumps. And this is a smart thing for the compiler to do. It's called peephole optimization. So just cut out this byte because we don't need it. We can say deterministically what's going to happen without ever touching this byte. So that's a smart thing for it to do. But it does screw up our coverage. Because we now can't write a test that actually determines whether or not that continue line executed. Because even in the case where it does execute, it still doesn't execute, if you know what I mean. So if you are Ned Batchelder, who's the author of coverage.py, this is a real problem. Because people report this saying, hey, I wrote a test that covers this case and I don't see it, what's going on. And this was the original motivation for writing the bytecode interpreter that he and I have been working on, because he was saying maybe I should be doing bytecode level coverage. And this turns out probably not to be feasible for a variety of reasons. But the other way to go is say, okay, well, can we turn off people optimization? And so in like 5 or so years ago, he had asked on the Python dev mailing list, can we turn off people optimization if like a flame war ensued? And then a couple of people brought it up to me unprompted in Python. He brought it up and referenced the issue number like 5 years later, and he still remembered. And another dev brought it up and said, probably you need a PEP, you need a Python enhancement proposal to make that change. And so he went and started another flame war on the mailing list. And it was determined that in fact there should be a PEP that just turns off the people optimizer. So if you're the author of, for example, a test coverage suite, you can just ignore that entirely. And in the future, if there are more optimizations to the compiler, you will probably want to be able to turn those off as well. And that'll be an advantage for you. So anyway, I'll push this code. If you have any questions about it, I'd be happy to talk to you.